Hello, my name is Ben Manning, and this is my final project for MAE 4733 with Dr. Bai. My design is representative of a completely automatic fan, where this DC motor represents the speed, it controls the speed of the fan, and the servo motor controls the oscillation. Now, it's a completely automated design. Therefore, it requires no user interaction. It will turn itself on and off automatically. It will vary its speed and will decide whether or not it needs to oscillate via a couple of conditions. And then through the use of serial communication, the status of the fan and the oscillator are monitored and displayed on this LCD. Now, the start point and the main governor of this design is through the TMP36 sensor. This sensor reads the temperature of the surrounding environment and sends a corresponding voltage to the Arduino. The Arduino then reassigns it a temperature value, seen here in Fahrenheit through this function, and decides whether or not the value is above the specified base, as here in 70. Now, if the value is above the specified base, then it turns on both the servo and the DC motor, as shown here. The DC motor, however, if is below a specified ceiling or a specified point in which the temperature is below a heightened temperature, the desired speed is controlled by a function of temperature, 1.25 times temp minus 81.25, which is a constant. While the servo is just kind of a constant swaying. Now, to adequately control the motor, I used a PID system here. And then another little constraint of the motor is that if motion is detected, the servo motor stops oscillating to concentrate airflow on a person rather than cooling the room. So it prioritizes cooling a person over the room. And then there are conditions assigned for each possible outcome. So if the system's completely turned off, if both motors are on, and if one motor's on while the other's off. And if these conditions are triggered, it prints a capital letter here that is printed through the master Arduino and sent and received by the receiver Arduino that takes each condition and assigns them to a certain action that will cause the LCD to print either on or off for each one. Alright, here we go. Starting up, initializing. So there you see that the fan is or was turning. I've been having issues with Tinkercad lately. The simulator has been going kind of slow, and I've actually sped this up. If you see here, this degree should be plus equal to 1 or 2, so that way it'd be going at a good rate. But you see that it's above, the temperature is above the specified rate, so therefore everything's moving. Now let's go over here. You will see this motion sensor, and I'm going to stop, it's triggering it. And there we go, see, you have the servo stopped and the oscillation is off. Now we wait for a second and it starts back on, or at least it will after the delay is reached here. Like I said, oscillation is turned back on and the servo continues. So now we have, this is a function of temperature still, but say it got real hot. You can see it's starting to pick up, but let's say it just dropped real quick. You can toggle that. And like I said, it's just everything is moving so slowly and I'm thinking it's just the sheer amount of components or something within Tinkercad. But it just takes a minute. But everything does indeed work you can see, even though it reads all of that, off and off, the motor's not moving, neither motor's moving. There we go. And now let's just bring it back up. So now the temperature should be above the specified base, and you can see the servo starting to move. And so what it's doing right now is it's printing the condition H, and the H is received through this Arduino using serial communication, and then it's displaying on for both. And that is the demonstration of my final project. As you can see, this project is more than feasible for a real-life application. I mean, obviously, values would have to be bigger in terms of power and motor to adequately control a fan, but you can see that the functionality would remain very much the same, and as you can see, the results speak for themselves. Have a great day, and thank you very much.